Um, Good afternoon, guys, or good morning, or good evening, wherever you are watching from. So, let's talk about Kirchhoff's law. So, we are going to calculate the current across each resistor in the circuits. The circuit we can see here. So, now, what I want us to understand is that when we are talking of this particular law, we are referring to two things: the current law and the voltage law. Now, we can see this battery 24 volts. This is the negative sign, while this is the positive sign. Current will always flow away from the positive terminal of the battery. So which means our current is going like this. Our current is going like this. Our current is going like this. Are we together? So here is your positive terminal for the resistor. Here is the negative. When your current is flowing, the first point you meet at the resistor will give your positive sign, while the second point will be your negative sign. Same thing, if the current is coming here, this first point of the resistor will be the positive sign, while the second point will be the negative sign. I hope you get it. So the current that is flowing, this is a junction. The current that is entering this junction, this particular point is a junction. So this current that is coming is entering the junction. And that same current is coming out of the junction. This is coming out. But this time it's coming out in two ways. It's coming out to this R2 resistor. It's also coming out, like going out to this R3 resistor. So let me tell you, the current that is going out in this way and the one that is going out of that junction in this way, the addition of those two are equal to the current that is coming into this junction. Are we together? So let's call this one our I1. Let's call this one our I2. Let's call this one our I3. So that's one. Now, from the KCL, Kirchhoff's current law, it said the current that is entering a junction, I1, equals to current, the total current that is leaving the junction. And we know we have two current leaving that junction, which are I2 and I3. So I1 equals to I2 plus I3. So that's for the KCL. Now the other one, the KVL, that's when we'll be using this arrow, this loop. So may I tell you, whether the direction of my loop is this or is this, it doesn't matter. In a much you follow the concept, you surely get the correct answer. That's one. Are we together? So don't forget the way we obtain the sign for this resistor. Your current will always flow away from the positive terminal of the battery, which is this. And as you are going, once you meet the resistor, the first point is your positive terminal, while the second end is your negative. As you are coming for the resistor, as you're also going, this one is your positive terminal for the resistor, this is the negative. As the current is coming, this is your positive terminal of the resistor, this is your negative terminal of the resistor. Are we together? So that's that for that. And what we are dealing with here, we are using this voltage. Is this battery that we are using to consider the flow of current? It is this voltage we are considering for the flow of current here. Are we together? Because if you are to consider this one, the flow of current will be going this way and it will go against this way. So it may change the order here, because if you want to consider this one, are we together? So here we have to be plus, here we have to be minus. Do you understand what I'm saying? But is this one we are considering? Are we together? Even though if you forget about this, you may not have to use this battery. You may decide to consider this battery and change the other way around. Positive, negative, positive, negative. Are we together? Positive, negative, positive, negative. You will still get your answer. Yeah, you will still get your answer. Oh yeah, now let's move on. Now, considering this loop, you can see the direction of the loop. Let me just do it. This loop, if this loop continue to move like this, know that it will go upward like this. Are we together? If the loop continue to move like this, it will come like this, also come like this. I'm just using it to show you how you are going to calculate your direction. And if the arrow is pointing from the positive to the negative of the terminal, that's voltage drop. Whatever value you have there is going to be negative. Once the arrow is pointing from negative to positive, positive to negative, it will be negative voltage drop. But when it's pointing from negative to positive, it will be positive, which is voltage rise. Now, you can also see the direction of the loop here. Now let's start. We are calculating all the voltage, the voltage of the battery, and the other voltage drops in the loops, in the first loop. Now for this one, we have 24 volts. We have to, it's going to be plus because this is negative to positive. So we're having plus 24. Now we are calculating all the voltage in this first circle, this loop. All the voltage. This is the first voltage. The other voltage, the second voltage is here because we have a current here, I1. This is it. This is the I1. We also have R1. And you know, Ohm's law, V is equal to IR. Voltage is equal to IR. So there's another voltage here. So we want to check if it is voltage drop or voltage rise. You can see that this is plus to minus. So it's going to be drop from positive to negative. That's a drop. So if you are going to add the voltage here to this one, it's going to be minus V, and you know V is IR. And which I do we have there? Which R? We have I1, R1. So now coming here, you see this also plus minus, plus minus, and this is I2, right? This is I2 and this is R2. The voltage drop there is drop actually because it's positive to the negative. The voltage drop there is going to give us minus what? I2, R2. Are we together? Equals to what? 0. Are we together? So that's our what's it called? Our KVL. That's our KVL for the first loop. So that's our KVL for the first loop. Why we equate it to 0? Because the thing state that the sum of all the voltage, the summation is equal to 0. Don't forget this, equals to 0 for the KVL. Now that's the second equation. This is the first equation from the KCL. This is the second equation from the KVL. Now for the third one, considering the second loop now, you can see this R2, this R2 have impact in the loop 1. It also have impact in the loop 2. For loop 2, see, if I'm to draw, R2 is included. Are we together? For loop 1 too, for loop 1, R2 is also included. R2 is also included. This R2 is included in the first loop. It's also included in the second loop. So you are going to consider it also. So if I'm to check the direction of this arrow, it's going to, if this arrow continue like this, you know, it will go up like this. Am I right? If it continue, it will go like this. Am I right? If it also continue, it will go like this. Am I right? If it also continue, it will go like this. So now considering this first, you know, for the arrow 2 in the first loop, it is minus, plus to minus, because the arrow is coming down. This is it, it's coming down, plus. But now in the second loop, it's going up, the arrow is going up, so it's minus to plus. Do you see it now? Minus to plus. So that's going to be what? Positive, no longer negative. So and we have I2 and R2 there. So our voltage there is what? Is voltage rise, which is what? Is going to be positive, I2, R2. Now if you continue again, this one is plus to minus, this arrow, so it's voltage drop, I3, R3, so it's going to be minus, I3, R3. Are we together? So the fourth one, yeah, please take note, here, this one is not R4, it's still R3 because this is a series connection. What do I mean by series connection? When you have a, you know, singular, a single pattern, a single part, even though it's bent, this is still a single part because I can make it to be straight. This is not a junction. This still, assuming this is a gutter, maybe I now curve the gutter like this. The total amount of water that is flowing here, all those water will still come here. We have the same water flowing here, the same thing will still be here because it's still one channel. The water flowing here may no longer be the same as the one flowing here if and only if we have another line like this. But since there is no another line like this, all the water, all the current flowing here will also come here. So it's this I3 that still continue to be here. Do you understand now? So here we have what? I3 again, which is coming downward from positive to negative. So since that's drop, voltage drop is going to be what? Minus what? I3 R4. Do we have any other things there? Yes. Now, if we come down and go like this, you see the voltage, this 29 volts. What do we have? Is from, for the loop, the arrow, positive to negative, positive to negative. So its voltage drop is going to be what? Minus, minus 29 volt. Everything equals to what? Is 0. This equation 1, equation 2, equation. So that's equation 2. Then we have what? Equation what? Equation 3. Are we together? So now let's change the order of the these two equation. Now for equation 2, we have all this negative we go to the other side. So we have it is changed to positive I1 R1. Okay, sorry, what's our R1? 3 ohms, are we? So 3 times I1. So we have 3 I1. This one too will go to the other side to become plus. What's our R2? 3 2. So that is plus 3 I2 equals to, this guy is not crossing. It's here. Leave it here. Equals to 24. It's just like it's on this side before, and these two are on this side. If I say s equals to y, it's same thing as y equals to x. So 3I1 plus 3I2 equals to 24. Let this still remain as our equation 2. It's still our equation 2. For the equation 3, we have was I2 R2. What's our R2? 3. So that will give us times I2, 3I2 minus I3 R3. What's our R3? 3 2 minus 3I3 minus I3 R4. What's our R4? 4. 4 times I3. We have minus what? 4I3 equals to, if this minus 29 go to the other side, we have what? 20 what? 29. So equals to 29. So these are what? Our equation what? 3. So this equation 3, sorry, we can still have it as 3I2, 3I3 minus 4I3. We have minus 7I3 equals to what? 29. So all those three equations, let me just bring them together. For the equation 1, for the KCL, we have I1 equals to I2 plus I3. For the equation 2, we have 3I1 plus 3I2 equals to 24. For the equation 3, we have 3I2 minus 7I2 equals to what? 29. So these are the three equations. 7I3 rather. These are the three equations. So what are we going to do now? Here we have I1, I2. We have I2, I3. There is no how we can solve the two simultaneously unless we have both I1 and I2 in the 2. If we have I1, I2 here, and we also have I1, I2 here, we can solve it. Or we have 2, 3 here and 2, 3 here. But how do we do it? We can substitute equation 1 to any of them. So what I would prefer to do now is to substitute I1 to equation 1. Like substitute I1 into equation 1. And what's my equation 1? 3I1 into equation 2 rather. This is my equation 2 and this is my what? Equation 3. This is my equation 1. So I'm substituting equation 1, I1, from equation 1 into equation 2. Equation 2 says 3I1. But what's my I1? I2 plus I3, right? I2 plus what? I3 plus what? 3I2 equals to 24. So at the end of the day, 3 times I2, I'm having 3I2 plus 3 times I3. Then I will be having 3I3 plus 3I2 equals to 24. 3I2 plus 3I2, I'm having 6I2 plus 3I3 equals to 24. So let me call this one now equation 4. Are we together? So what is our equation 3? This is our equation 3. So let me bring it down. My equation 3 now, I want to bring it down. Are we together? I'm bringing it down. My equation 3, which says 3i2 minus 7i3 equals to 29. You can see now they are common now. 2, 3, they have common missing terms. I2, I3, I2, I3. So you can solve simultaneously. How do you do that? How do you solve simultaneously? It's very easy. You can decide to find I2 first. You can decide to find I3 first. So if I want to find I3 first, I will have to multiply the two equation by the coefficient of I2. If I want to find I2 first, I will have to multiply by the coefficient of I3. So I decide to find I3 first. Whichever way you want it, you still get your answer. So I decide to find I3 first. Let me multiply. Now I want to use elimination. Let me multiply by the coefficient of I2. So you are multiplying equation, the second one, our equation 3. You are multiplying it by the coefficient of I2 in equation 4. That is the one at the down. You are using the coefficient of the one at the top. The one at the top, you'll be using the coefficient of the one at the down. So this one will give us times 3. No, here, but here we have 6. So this one will give us times 6. So 3 times everything here and 6 times everything here. So 3 times everything here, 3 times 6i2, we have 18i2 plus 3 times 3i3, we have 9i3 equals to 3 times 24. 3 times 24, what do we have? So we have 72. So 6. So now, sorry, the fact that they are plus plus, they are plus plus. So you have to add negative to any of the two so that they can cancel out. Assume I find I2 first. Maybe I'm now using the coefficient of I3. I don't need to add any negative here because they contain opposite sign already. They will cancel out at the end of the day. But I'm using this, they have the same sign. So you have to add negative to anyone. So let me use this 6. Let me add negative to this one. Are we together? Oh, okay, don't worry. You don't even need it. Continue. You can continue like that. Don't worry, don't panic. So let's just use the 6 like that. We still get our answer. So that's 72. You understand to this point. 6 times 3i2, we have what? 18 what? 18i2. Then 6 times 7 minus 7, we have minus 42i3 equals to 6 times 29. Let's just say 6 times 30, that gives us 180 minus 6. That gives us 174. Yeah. 9 times 6. Yeah, 174, I'm right. So now, what are we going to do? We subtract. Yeah, we subtract. So instead of using the minus here, don't worry. You can just put the 6 direct, 3 direct, and do your multiplication. So what do we do now? We subtract. So if you subtract this minus this, they cancel out. Plus 9 minus 42. Don't forget this minus because we are subtracting. 9i2 minus 42. 9i3 rather minus 42i3. So minus change to plus. It's just like you are adding now because you have minus and minus. So 9 plus 42, that gives us 51, right? 51i3 equals to now 72 minus 174. What do we have? 72 minus 174. So we have minus 102. Minus 102. So now divide both sides by 51. So your I3 will give you minus 102 over 51. You have minus 2. That's your I3. Minus 2. That's our I3. Are we together? Now we can substitute this to either equation 4 or 3 to get our I2. So I prefer to use equation 4. So now equation 4, I'm having 6i2 plus 3i3. My I3 is minus 2 equals to 24. So I'm having 6i2 plus 3 times minus 2. I'm having minus 6 equals to 24. 6i2 equals to 24 plus 6, which is same thing as 30. So I2 will give me 30 over 6. 30 divided by 6, that's 5. My I2 is equal to 5. My I3 minus 2, my I2 equals to 5. Now, we say from the KCL, we say I1 equals to I2 plus I3. So I1 equals to I2. What's my I2? 5 plus I3. What's my I3? Minus 2. So it's equal to what? 5 minus 2. I'm getting 3 ampere. This ampere. And this also what? Ampere. So my I1 now is 3 ampere, I2 is 5 ampere, I3 is minus 2 ampere.